All right, wow, you've really outdone yourself this time. This stack of articles and research all about tsunamis is impressive. I can already tell this is going to be a fascinating deep dive.
Yes, indeed. It appears we have a lot to unpack here, a very thorough mix of sources covering everything from historical accounts to the latest scientific findings.
You got that right. We've got historical accounts, explanations of how these waves form, and even some in-depth stuff on early warning systems. So let's just dive right in. The first thing that jumps out at me is the word tsunami itself. A few of your sources mention the Japanese origin, meaning harbor wave. That sounds pretty descriptive, I guess, but I'm guessing it doesn't quite capture the full picture, does it?
Well, you're right to be cautious about that translation. While a tsunami might hit harbors particularly hard, focusing only on that, undersells the sheer scale and power of these events. The crucial difference between a tsunami and those wind-driven waves, the ones we see at the beach, all lies in their energy source. Wind creates surface waves, but a tsunami is generated by something far more powerful. A massive displacement of water.
So it's not just about the size of the wave, but the sheer force behind it.
Right.
Speaking of terminology, I noticed a few sources using the term tidal wave. Is that accurate, or is that something scientists would prefer we avoid?
You're spot on. That's a pet peeve for many of us in the scientific community. While a tsunami might resemble an exceptionally high tide when it reaches the coast, it has absolutely nothing to do with the moon's gravitational pull or regular tidal patterns.
Yeah, right.
Tides are predictable and cyclical, whereas tsunamis are triggered by sudden, often catastrophic events.
So let's officially retire tidal wave then. Now, I have to admit, I was surprised by the variety of things that can actually cause tsunamis, according to your research. Earthquakes, sure, but some of the other culprits were quite unexpected.
You're right. Earthquakes are often the first thing that comes to mind, but they're just one piece of the puzzle. The common thread linking all tsunami triggers is that they cause a rapid and significant displacement of water. Think of it like dropping a bowling ball into a bathtub.
Okay.
It creates a miniature version of what happens on a much larger scale with tsunamis.
Okay, that's a helpful image. So let's break down these various causes. You mentioned earthquakes, but I read that not all earthquakes lead to tsunamis. What's the difference?
You're right. Not all earthquakes are created equal in this regard. The type of earthquake that triggers a tsunami needs to cause a vertical shift of the seafloor. This is where those megathrust earthquakes come into play, the ones capable of generating tsunamis that can travel across entire oceans.
Right. Those are the ones that cause the most widespread devastation, like the 2004 Indian Ocean tsunami.
Exactly. But then we have landslides, both underwater and above water, which can be equally dramatic, though perhaps not as widely understood. There's a fascinating account in your research about the 1958 Lituyu Bay megatsunami in Alaska. It was triggered by a massive landslide and produced the tallest wave ever recorded at a staggering 524 meters high.
524 meters. That's taller than some skyscrapers. It really makes you realize just how powerful nature can be.
It's a stark reminder of the forces at play. And then, of course, we have volcanic eruptions. It's not just the lava flows we need to be concerned about. Eruptions can trigger those massive landslides we just discussed. Or if a large eruption occurs underwater, the explosion itself can displace enough water to create a tsunami.
So we've got earthquakes, landslides, volcanoes. Is there anything else we're missing?
Believe it or not, even the weather can cause tsunamis, though on a smaller scale. These are called mediate tsunamis, and you've included an interesting case study from Menorca in 2006, where rapid atmospheric pressure changes associated with a passing weather front generated a tsunami that caused millions of euros in damage.
So it's not just the Earth itself, but the atmosphere can trigger these events as well. That's incredible. I also noticed a few articles mentioning humans as a potential cause of tsunamis. Is that even possible?
It is, although thankfully not on the scale of natural events. One of your sources details the Halifax explosion of 1917. A massive accidental explosion in the harbor generated an 18-meter-high tsunami. A stark reminder that our actions can have unintended consequences, even when it comes to forces of nature. On a slightly more unsettling note, there were even attempts during World War II to weaponize tsunamis, though those, thankfully, failed.
That's a chilling thought. So we have a whole spectrum of causes, from shifting tectonic plates to landslides, volcanoes, weather patterns, and even human activity. It makes you wonder what it actually looks and feels like to experience a tsunami. I mean, how does it differ from a regular wave?
That's where things get really interesting. Imagine you're out on a boat in the deep ocean and a tsunami passes beneath you. You might not even notice it.
Wait, seriously, why would that be?
It all comes down to two key factors: wavelength and wave height. Tsunamis in deep water have incredibly long wavelengths. We're talking hundreds of kilometers.
Wow.
Compare that to the much shorter wavelengths of wind-generated waves. And while the tsunami might eventually build to monstrous heights, out in the open ocean, it might only be a meter or so tall, almost like a gentle swell.
So it's kind of like a sleeping giant lurking beneath the surface.
That's a great way to put it.
Yeah.
It's precisely this stealthy nature that makes them so dangerous. But as the tsunami approaches the coast, things change dramatically.
This is where things start to get really scary, right?
Absolutely. As the water gets shallower, the tsunami slows down. That long wavelength starts to compress, and all that energy gets focused into a smaller area, causing the wave height to increase dramatically.
Okay, that makes sense, but why doesn't the wave just break like a regular wave when it gets that tall?
That's a great question. It's because the physics are different. Think of it like a figure skater pulling in their arms as they spin. They don't suddenly stop spinning. They spin faster because their energy is now concentrated in a tighter space. With tsunamis, as the wave enters shallower water, friction with the seabed slows the bottom of the wave while the top continues moving at a faster speed. This difference in speed, combined with the compression of the wave's energy, forces the water upward, creating that towering wall of water we associate with tsunamis.
That's a great explanation. I can see why they're so much more powerful than regular waves. And now I also recall reading about a phenomenon called drawback, where the sea recedes dramatically before a tsunami hits. It almost seems counterintuitive, like it would lure people toward the danger rather than away from it.
You're absolutely right. It is counterintuitive, and that's precisely what makes it so dangerous. Before a tsunami strikes, the sea can actually recede far beyond the normal low tide line, exposing vast areas of the seabed. Sadly, many people throughout history have misinterpreted this drawback as a harmless oddity, even venturing out to explore the newly exposed shore.
The 2004 Indian Ocean tsunami is a heartbreaking example of that, right?
Tragically, yes. Many people were caught unaware because they were drawn to the shoreline by the receding water, not realizing the monstrous wave that was about to hit. It highlights the importance of understanding these seemingly unusual signs and knowing how to react appropriately.
So we have a good understanding of the various causes of tsunamis and how they behave, but how do scientists measure the power of these waves? It's not like they can just break out a giant ruler, right?
You're right, it's a bit more complex than that. Scientists use different scales to assess the intensity and magnitude of tsunamis.
Can you explain the difference between intensity and magnitude in this context?
Intensity focuses on the observed effects of a tsunami at a specific location, similar to how the modified Mercalli intensity scale measures the shaking experience during an earthquake. The Soloviev-Imamura scale is one example of a tsunami intensity scale, and it uses the average wave height observed on the nearest coastline. For example, a 5.5-meter wave would be classified as intensity 3, while an 11-meter wave would be intensity 4.
So it's like the Richter scale for earthquakes, but for tsunamis, we look at the height of the waves at a specific point.
Exactly. Magnitude, on the other hand, looks at the overall energy released by the event, similar to the moment magnitude scale for earthquakes. These scales for tsunamis are more complex to calculate, but they give us a broader picture of the event's power.
That makes sense. So by analyzing wave height and the energy released, scientists can get a sense of how powerful a tsunami is. But what about predicting them? Is there any way to know when and where a tsunami might strike?
Thankfully, we've made significant strides in that area with the development of early warning systems.
That's reassuring, especially considering how devastating these events can be. Can you tell us more about how these warning systems work?
They rely on a network of technologies and systems working together. First, we have seismic monitoring networks around the world, constantly looking for earthquakes that could potentially trigger tsunamis. Then we have deep ocean buoys equipped with pressure sensors. These buoys can detect even the slightest changes in sea level caused by a passing tsunami, even while it's still in deep water.
It sounds like those buoys are our eyes and ears out in the ocean, constantly watching for any signs of trouble.
That's a great way to think about it. Once these buoys detect something, the data is fed into sophisticated computer models. These models use information from the sensors, combined with knowledge of seafloor topography and coastal features, to predict where the tsunami is headed and how big it will be when it reaches the shore.
So it's like having a giant puzzle, and the computers are putting the pieces together to figure out the path of the tsunami.
Precisely. And finally, once the models have generated their predictions, the information is disseminated through public alert systems. This could involve sirens, text messages, radio and TV broadcasts, anything to get the word out as fast as possible.
This brings to mind the story of Tilly Smith, the 10-year-old girl who saved lives in the 2004 tsunami because she had learned about drawbacks in school. It's a powerful example of how education and awareness can make a real difference.
Absolutely. Her story is a testament to the power of knowledge and how even young people can play a vital role in disaster preparedness.
So we have these incredible warning systems in place, which is a huge step forward. But what else can people do to protect themselves from tsunamis, besides the obvious heading for higher ground when a warning is issued?
You're right, evacuation is always the priority. But there are other measures that can help mitigate the risk. In some tsunami-prone areas, they've constructed massive seawalls, some as high as 12 meters, to try and block or reduce the impact of the waves. Japan, for instance, has invested heavily in these types of structures.
But even those haven't always been enough, right? I read about how some of the seawalls in Japan were overtopped by the waves during the 2011 tsunami. Are there any other limitations to these structures?
You're right to point that out. No mitigation measure is foolproof. Tsunamis can be incredibly powerful and in some cases exceed our best defenses. However, even when a seawall is overtopped, it can still play a crucial role in reducing the wave's force, buying valuable time for people to evacuate.
It's about buying time and minimizing the damage as much as possible.
Exactly. Other mitigation strategies include things like floodgates and channels to redirect water away from vulnerable areas, designing buildings to be more earthquake resistant, and carefully planning land use to avoid development in low-lying coastal areas.
It seems like a multifaceted approach. Combining early warning systems with structural defenses and smart land use planning is key.
Precisely. It's about recognizing the risk, being prepared, and taking steps to minimize the potential impact of these powerful forces of nature.
This deep dive has already been incredibly insightful. We've covered so much ground, from the science of tsunamis to how they form and the measures we can take to prepare for them. What else do you have in store for us?
Now that we've covered the basics, let's delve into some specific historical examples of tsunamis to see how these events have unfolded in the real world.
I'm ready for some tsunami tales. Let's hear it.
Let's start with the 1755 Lisbon earthquake and tsunami. It's a fascinating and tragic story that profoundly impacted European thought and our understanding of natural disasters. The Lisbon earthquake, as its name suggests, struck Lisbon, Portugal. On the morning of November 1st, 1755, which happened to be All Saints' Day, it was a massive earthquake, estimated to be somewhere between 8.5 and 9.0 on the moment magnitude scale.
Wow, that's a level of magnitude that's hard to even grasp. I can only imagine the devastation it must have caused. What was the immediate impact like?
The earthquake itself caused widespread destruction throughout Lisbon. Buildings crumbled, fires ignited almost instantly, and chaos reigned in the streets. However, the worst was yet to come. About 40 minutes after the initial tremors subsided, a series of 3 colossal waves, some reaching as high as 30 meters, crashed into the Portuguese coastline.
30 meters, that's the height of a 10-story building. It's hard to even comprehend the scale of those waves.
The destruction was truly catastrophic, and these waves weren't just confined to Lisbon. They radiated outward across the Atlantic Ocean, striking coastal areas in North Africa, Spain, and even reaching as far as the Caribbean. The combined death toll from the earthquake and tsunami is estimated to be somewhere between 60,000 and 100,000 people.
That's a staggering loss of life. It must have left an indelible mark on the survivors.
The impact went far beyond the immediate physical destruction. The Lisbon earthquake and tsunami had a profound effect on European thought and philosophy. It challenged the prevailing view that natural disasters were divine punishments from God. It sparked fierce debates about the nature of evil, the role of suffering in human existence, and ultimately, the role of reason in understanding the natural world.
So this one event actually triggered a philosophical crisis. That's quite remarkable.
It did. Thinkers of the Enlightenment, like Voltaire and Rousseau, grappled with the implications of such a catastrophic event. It forced them to question the concept of a benevolent God and grapple with the problem of evil. This questioning led to the exploration of new ideas and philosophies, including a greater emphasis on scientific inquiry and empirical observation.
It seems like a powerful example of how a natural disaster can be a catalyst for intellectual and cultural change.
Precisely. It shifted the focus from interpreting natural events through a purely religious lens towards seeking scientific explanations and understanding the mechanisms behind these phenomena. This led to advancements in fields like seismology and the study of tsunamis, laying the groundwork for our modern understanding of these events.
That's a fascinating insight. Out of tragedy came a new way of thinking about our world.
It's a testament to the resilience of the human spirit. We strive to make sense of the world around us, even in the face of devastating events. The Lisbon earthquake and tsunami marked a turning point in our understanding of these phenomena. And while we still have much to learn, we've come a long way in terms of predicting, warning about, and mitigating the risks posed by tsunamis.
Speaking of historical tsunamis, the 2004 Indian Ocean tsunami is one that's seared into my memory. The scale of destruction was just unimaginable. What made that event so impactful?
The 2004 Indian Ocean tsunami was triggered by one of the most powerful earthquakes ever recorded, a magnitude 9.1 megathrust earthquake off the coast of Sumatra, Indonesia. The energy released by this earthquake was simply staggering, and the resulting tsunami waves were some of the largest ever observed, with some reaching over 30 meters in height.
I remember the news footage vividly. The sheer scale of the destruction was hard to comprehend. Entire coastlines were reshaped and communities were simply wiped away.
It was a stark reminder of the immense power of nature. The tsunami waves, radiating outward from the earthquake's epicenter, devastated coastal communities across the Indian Ocean, impacting countries like Indonesia, Sri Lanka, Thailand, and India. Tragically, even distant shores in East Africa were affected by the waves.
Wasn't there a significant delay in the warning system which contributed to the high number of casualties?
You're right, that was one of the contributing factors to the devastating loss of life. At that time, the Indian Ocean region lacked a comprehensive tsunami warning system, like the one in place for the Pacific Ocean. Many people were caught completely off guard, with little or no warning of the approaching waves. The death toll was truly heartbreaking. Over 230,000 people lost their lives.
It's a sobering reminder of the importance of early warning systems and the need for them to be in place globally. We can't afford to underestimate the threat posed by these events.
Absolutely. The 2004 tsunami was a wake-up call for the entire world. It highlighted the critical need for improved preparedness on multiple levels, not just in terms of technology and infrastructure, but also when it comes to education and raising public awareness.
Since then, we've seen advancements in tsunami detection and warning systems. But are there other historical tsunamis you believe are essential for understanding the evolution of our knowledge and preparedness?
Definitely. The 1960 Valdivia earthquake and tsunami stand out as a particularly significant event. It was triggered by the largest earthquake ever recorded, a magnitude 9.5 off the coast of Chile. Imagine the energy released by an earthquake even larger than the one that caused the 2004 Indian Ocean tsunami.
It's hard to fathom an earthquake of that magnitude. What were the impacts of the tsunami it generated?
The tsunami waves caused widespread destruction along the Chilean coastline, reshaping the landscape and causing significant damage to infrastructure. But the impact extended far beyond Chile. The waves traveled across the Pacific Ocean, impacting Hawaii, Japan, and other Pacific Rim countries.
These events truly demonstrate the interconnectedness of our world, how an event in one part of the globe can have far-reaching consequences.
They underscore the global nature of these events and highlight the need for international collaboration in research, monitoring, and disaster preparedness. Each of these historical tsunamis, while tragic in their impact, has provided invaluable data and insights that have helped us refine our understanding and improve our response to these powerful forces of nature.
It's a reminder that even in the face of nature's raw power, we can learn, adapt, and build resilience. Speaking of preparedness, one thing I was curious about is the concept of tsunami evacuation maps. Are those something everyone living in or visiting coastal areas should be aware of?
Absolutely. Tsunami evacuation maps are a crucial tool for anyone living in or traveling to coastal areas at risk of tsunamis. These maps provide designated evacuation routes and identify safe zones, typically on higher ground, that you should head to if a tsunami warning is issued.
So it's not just about knowing the risk, but having a clear plan in place. Knowing where to go and how to get there can make all the difference in an emergency.
Exactly. In a tsunami situation, every second counts. You don't want to be scrambling to figure out where to go when the waves are already approaching. Having a predetermined plan can help you react quickly and calmly, increasing your chances of survival.
Where can people find these evacuation maps? Are they readily available?
Most coastal communities at risk of tsunamis make these maps readily available to the public. You can often find them online, on government websites, at local community centers, or even posted in public areas along the coast. It's always a good idea to familiarize yourself with these maps, especially if you live in or are planning to visit a coastal area.
It sounds like it's worth doing a little research ahead of time to be prepared.
It's always better to be prepared than caught off guard. Knowing where to go and what to do in a tsunami emergency could quite literally save your life.
This has been an incredible journey through the history of tsunamis. It's both fascinating and sobering to see how these events have shaped our understanding of these powerful forces of nature. But what more can we learn from these events? What insights can they offer beyond the science and the statistics?
That's a great question. I think one of the most important takeaways is that while we've made significant progress in understanding and preparing for tsunamis, they serve as a powerful reminder of the immense forces of nature that shape our planet and remind us that we are ultimately at their mercy.
That's a powerful thought. It's a humbling experience to realize the power of nature and our place within it. But despite this vulnerability, we've shown incredible ingenuity and resilience in developing the technology to predict and prepare for these events.
Absolutely. And that resilience is something we see time and again in communities that have been impacted by tsunamis. They rebuild, they adapt, and they carry on. It's inspiring to witness the human spirit's ability to overcome adversity.
So we have the knowledge, we're developing the technology, and we're learning to adapt and rebuild. What does the future hold for our understanding of tsunamis? Are there any emerging areas of research or new technologies on the horizon that you're particularly excited about?
Well, there are several promising avenues of exploration. One area that holds immense potential is the use of artificial intelligence and machine learning to enhance tsunami forecasting and warning systems.
That sounds fascinating. Using AI to predict tsunamis, how does that work?
By feeding massive amounts of data into sophisticated algorithms, we can train these systems to recognize patterns and make predictions with a level of accuracy we could only dream of before. This data includes information from past tsunamis, earthquake records, seafloor mapping, and of course real-time data from those deep ocean buoys we discussed earlier.
So it's like having a supercomputer analyze all of this information and help us anticipate these events more effectively. Are there any specific ways this technology is being implemented?
Absolutely. For instance, AI can help us generate more detailed and dynamic tsunami evacuation maps. These maps take into account factors like local geography, population density, and even traffic patterns to optimize evacuation routes and minimize the time it takes for people to reach safety.
That's incredible. It sounds like AI is poised to revolutionize how we approach tsunami preparedness. Are there any other innovations on the horizon that you're particularly excited about?
Another area that's generating a lot of buzz is the development of tsunami-resistant building designs and materials. You mentioned earlier how some seawalls were overtopped by the waves in the 2011 tsunami. While those structures still played a vital role in reducing the impact, researchers are constantly looking for ways to make buildings even more resilient to the immense forces of a tsunami.
So it's not just about trying to stop the waves entirely, but also designing structures that can withstand them if they do reach the shore.
Exactly. This could involve using reinforced concrete, incorporating innovative structural designs that allow buildings to flex and absorb the impact of the waves, or even elevating structures on stilts or platforms to allow the water to flow beneath them.
It sounds like a perfect marriage of ancient wisdom, like building on higher ground and cutting-edge engineering.
Precisely. We're taking lessons from the past and combining them with the latest technological advancements to create a safer future. And it's not just about the physical structures. The human element is equally crucial. As our understanding of tsunamis evolves, so too does our approach to community education and disaster preparedness training.
So it's not just about the technology itself, but also empowering people with the knowledge and skills they need to stay safe.
Absolutely. We're seeing a growing emphasis on community-based disaster preparedness programs. These programs teach people about tsunami risks, conduct evacuation drills, and help communities develop effective emergency plans. This type of grassroots approach, where individuals are empowered to take action, can make a significant difference in saving lives.
That's encouraging. It sounds like we're moving towards a more holistic approach to tsunami preparedness, combining technological advancements with community engagement and a deeper understanding of these powerful events.
You've hit the nail on the head. It's about recognizing that we can't rely solely on technology. We need to build resilient communities that are informed, prepared, and able to respond effectively when these events occur.
This deep dive has been incredibly insightful. We've explored the science behind these giant waves, delved into historical events that have shaped our understanding, examined the technology that's helping us predict and prepare for them, and highlighted the importance of community engagement and education. It's been a fascinating journey into the world of tsunamis. Do you have any final words of wisdom for our listener as they continue to explore this topic?
Tsunamis are a powerful reminder of the forces of nature that shape our planet. They can be destructive and awe-inspiring in equal measure. But they also highlight the ingenuity and resilience of the human spirit. By learning from past events, embracing innovation, and working together, we can build a safer and more resilient future for ourselves and for generations to come. And for you, dear listener, keep asking questions, keep learning, and stay curious about the world around you.
Beautifully said. That's a perfect note to end on. Thank you for joining us on this deep dive into the world of tsunamis. We'll be back again soon with another fascinating exploration of knowledge and discovery.